Welcome to this platform. So in this video, let us go through the 2024 ECZ Science Paper 1, which is Physics, the one that the school certificate did. Okay, so this is the school certificate paper for 2024. All right, so this paper comprises of 85 marks. It is in parts. So the first part is for multiple choice, which is section A. And this is the one that we are going to go through in this video. So without wasting time, let us look at how the question came. So here is the first question that we are answering. So please, multiple choice or first section is 20 marks. And you need to choose the answers. That is multiple choice. So the first question was this one. The diagram shows an extract from a Vernier calipers being used to measure the diameter of a pipe. What is the reading of the instrument? What is the reading of the instrument? So how do you get the reading on the Vernier calipers? Okay, so to get the readings on the Vernier calipers, you need to find the main scale reading, of which the main scale reading you pick it before, immediately before the Vernier scale. The Vernier scale runs from 0 to 10. So this down here is the Vernier scale. The one that is on top here is the main scale. Starting from this side, immediately before you cross the Vernier scale. So you shouldn't cross this line. Immediately before you cross the Vernier scale, or immediately before the start of the Vernier scale, you pick the reading for the main scale. And therefore our target is this one. Okay, so that is the division that we are targeting. Now, how do we find the number here at this point? If we have 10 ahead, we do not have a number here. If we had a number here, would have started counting from here going this side, but we do not have. Instead, the 10 is ahead. So one thing that you should know, that each division on the main scale, it is 0.1 centimeter. So each division is 0.1 centimeter if the instrument is given in centimeter like this. So now to find the reading at this point, the only way out is to subtract a 0.1 per division that we move. In other words, we are going to move backward. So we are going to move how many steps? One step. So one step is just one division, which is a 0.1. So we are going to subtract 10. We can say 10.0 minus 0.1. 10.0 just the same as 10. Okay, so 0.1 is per division. Since we've gone back behind 0.1 step, so we subtract to find the point here. So we are going to say 1 minus 0, or 0 minus 1 is we put a 1 there. So 10 minus 1 is a 9 point. Then here you remain with a 9. 9 minus 0 is a 9. So therefore the main scale reading is 9.9. Or you can just subtract a 0.1 minus 10 since you use the calculator. So 9.9. Then the Vernier scale reading, how do we find the Vernier scale? So for the Vernier scale, you look at where it is coinciding, the main scale and the Vernier scale. Okay, to find the readings here, you find the Vernier coincidence. So this is the line that is coinciding, okay, that is continuously from the main scale to the Vernier scale. So that is where you pick the reading. And of course, you should know that on the Vernier scale, each division is a 1 centimeter. Okay, so 1 centimeter. So here, as you can see, from 0, 1, 2, so that is a 2. But you multiply it with 0.01, which is the accuracy of the instrument. Okay, that is the least count. So 2 multiply 0.01, you're going to have 0.02. Then you add 9.9 plus 0.02. You're going to have 9.92, and therefore the reading here is B, or the answer is B. Okay, I guess here you've gotten something. And of course there's more recordings. I think there's a recording on just how to get the readings on the Vernier calipers. You might want also to go through that. Otherwise, that is how you find the reading. Up to question 2. The swing of the simple pendulum, whose angle of swing, which is the amplitude, is 10 degrees, has a periodic time of 0.80 seconds. What would be the periodic time if the angle of swing is reduced to 7 degrees? Now here, you don't even need to calculate anything here, as you can see. You just need to know the factors that affect the period of the simple pendulum. 1, acceleration due to gravity, and also the length of a simple pendulum, and never the amplitude. So the factors that do not affect are 1, amplitude, and also you can talk of maybe the size of the bulb. Those do not affect the period of the simple pendulum, or they are independent from the periodic time. So therefore, here it remains the same, and the answer is A. So it remains the same, nothing changes. So the amplitude does not affect the period of the simple pendulum. So the answer therefore is A. Question 3. A digital balance reads 50 kg when a girl stands on it. So 50 kg is the mass of the girl on it. What would be the mass and the weight of the girl on the surface of the moon, where the gravitational field is given as 1.7? So gravity is equals to 1.7 Newton per kg on the moon. Now, one thing you should know about mass is that mass does not change. So when they ask you on the moon, mass will still be 50. So here we are looking for the answer that has the mass 50. So these two, we can cancel them in advance, okay, because mass cannot change. So we have A and B. Now, let us calculate the weight. Weight is dependent on gravity. And of course, as you move from Earth toward, or you go to the moon, weight decreases due to decrease in gravity. So weight is equals to mass times gravity. Okay, so 50 multiplied by 1.7. And this should be able to give you 85 Newton. We are looking for the one that has mass 50 and weight 85. Therefore, the answer is B. I guess here we are together. All right, let us look at question 4. The following diagram shows the motion of the ball that was dropped from a height of 2 meters and bounced back. Okay, so it bounced back. At what point A, B, C, and D is the ball having 0 speed? So when you throw something, at some point it stops momentarily before it starts moving, coming down. So where it stops momentarily, just for some milliseconds, at that particular point it has 0 speed. And therefore, here the answer is B. Okay? Then, of course, question 5, a ball was kicked vertically upward. So we can picture it was kicked vertically upward. This is the ball that was kicked vertically upward with the ball was kicked vertically upward, and the velocity, with a velocity of 8 meters per second. So initial velocity of the ball was 8 meters per second. Now, when it stops momentarily there, the final velocity is equals to 0 meters per second. Then when it starts coming down, the initial velocity is 0 meters per second. Okay? Now, what is the question here? How high did it rise? How high did it rise? So we are looking at gravity. Now, when you kick something upward, okay, there's acceleration. Acceleration is negative this side. So acceleration, we can pick 10 meters per second square, but also you can use 9.8 meters per second square. But one thing that you should know that is negative. When it starts coming down, it's negative because you are going against gravity. But when it starts falling down, the acceleration becomes positive meter per second square. Okay, so this is the information that you should know. By just knowing that the ball was kicked vertically upward, you know that acceleration on Earth is 10 meters per second square. And of course, because it was kicked upward, the acceleration is negative. Okay, initial velocity is 4 meters per second because they're saying it was kicked with the velocity. So the initial is 8. Then final, of course, when you stop momentarily there before it starts dropping, it is 0. So So what are we calculating here? We are calculating height because they're saying how high did it rise. So now, how do you calculate height, or which formula are we going to use? We are going to use this formula. So V square is equals to U square plus 2A X, okay, where X is the distance, okay, X is distance. But in this case, we are looking at vertical distance, which is height. So we can even put height where there's H. Okay, so this is the formula that we are going to use. We need the formula that has acceleration in it and velocity, that is the initial and the final. So the final velocity here is, we are talking of 0 meter per second. So 0 square equal to, initial is 8 square plus acceleration here is -10. Then of course height, which is h. All right. So now what happened here is that this is 0, this is 64, then this is negative, because this is going to be negative 20 h. We can bring 64 the other side to be 64, negative 64 equals to negative 20 h. We divide both sides by negative 20, divide negative 20, and therefore h, which is the height, is going to give us, what is 64 divide 20? 64 divide 20 should be able to give us 3.2. In this case is a meter. Okay, so this is the answer that we are looking for, and therefore the answer is C. All right, we continue with question 6. So for question 6, it's saying the following diagram shows a wheel used to drive a grind mill. Okay, what is the mechanical advantage? So mechanical advantage of this one is equals to driven wheel divide driving wheel, divide driving wheel. So the driven wheel is 50 centimeter, the driving wheel is 10 centimeter. If we are to divide here, mechanical advantage is going to give us what? Mechanical advantage is going to give us 5. And these are ratios, so no units. So 5.0. That is the answer. Question 7, a boy of mass. So we have mass of a boy 50 kg. A boy of mass 50 kg runs up a flight of stairs in 10 seconds. So time it took is 10 seconds. So it's very important that you correct the information. The vertical height of the stair is 5 meters. So height is equals to 5 meters. What is the average power developed by the boy? Okay, what is the average power developed by the boy? So the average power is equals to work done over time, or energy over time. So therefore here, to calculate power, we are going to find the energy, which is potential energy, divide time. Potential energy is equals to mass times gravity times height. So mass is 50 times gravity on earth is 10, multiplied by height, which is 5, divide 10. On top there, we are going to have 50 times 10 is 500, times 5 is 2,500, divide 10. So it just drop zeros and we are remaining with 250. Power is in watts, and therefore the answer is C. All right, question 8, a copper rod is heated at one end. Which statement describe how heat transfer occurs in the copper rod? So heat transfer occurs by, or is moved by the electron, delocalized electron, freely moving electrons from the hotter region to the cooler one. Okay, so here, if we were to look at the first one, energetic copper molecules, no. Energetic copper molecules, no. Energetic free electrons move from the cooler, no. Energetic free electrons move from the hotter end to the cooler end. So D is the answer here. Question 9, the following diagram shows the firearm. The bimetallic strip is used to complete the circuit when there is fire. So as you can see, this is the bimetallic strip. Now you know that the bimetallic strip is made up of two metals. one expand most than the other. Okay, so the one that expand most is the one that is the outside. So this one expand most, so that when it expand, it form this shape, and of course it will be able to complete the circuit here because it's going to move like that. Now, what are the questions, or what is the question? Which of the following statement is true when the alarm is when the alarm rings? So when the alarm rings, which means there's complete circuit here, which means it touches there, and that can only be when the metal outside expand. So metal A contract more than metal B. Let us reserve this one. Metal B contract more than metal A. Metal A expand more than metal B. We know that metal B expand more than metal A. So the answer therefore is D. So that when it expand, this expand is going to curve that way, and of course it will touch there, causing the alarm to what? To ring. Okay. Then question 10, which statement is true when water wave move from the deeper water to the shallow water? So the statement that is true here is that wavelength decreases. Okay, so therefore the answer on question 10 is wavelength decreases is C. Okay, so the wavelength decreases. Question 11, the diagram shows a meter rule clamped at one end and set into vibration. It produces 300 vibration in 2 seconds. Calculate the frequency. So number of complete vibration is equals to 300 vibrations, as it is indicated here. Then of course the time taken is 2 seconds. Calculating the frequency, we are going to use the formula frequency is equals to, you know that frequency is a number of complete vibration per unit time. So therefore number of complete vibration divide time. 300 vibration divide 2 seconds. We are going to have 150 frequencies measured in hertz. So 150 hertz, and therefore the answer here is B. Question 12, if 5 seconds elapse between a lightning flash and the clap of the thunder, how far away is the storm if the speed of sound in air is 340 seconds or meter per second? Okay, if 5 second claps, if 5 second elapse between a lightning flash and the clap of the thunder, how far away is the storm if the speed of sound in air is 340 meter per second? So here, how far is, we are looking at distance. So to write the formula, speed is equals to distance over time. So in this case, what is the speed? The speed is 340 meter per second. We are looking for distance. Then time, it is 5 seconds. So here you cross multiply. D therefore is equals to 340 meter per second multiplied by 5 seconds. Second and second cancel. If you multiply 340 multiplied by 5, should be able to give you 1,700, in this case, meter. So that is how you work this one out. Up to question 13. The diagram below shows the reflected ray from a plane mirror to an observer. Okay, which letter A, B, C, and D shows the position of the object? So for the object to be observed, it cannot be on the other side of the mirror. You know that mirror has to do with reflection. So therefore, for it to be observed, it cannot be on the other side. Only the image can be on the other side. This is the mirror line. Okay, so therefore you expect the object to be on this part of the mirror, and therefore it cannot be this one. Look at the rays, how they are moving. So this is the one that is here. Okay, so this is the one. So you're able to reflect, and of course is seen on the other side. Therefore the answer here is C. Okay, that is for question 13. Then question 14, the following diagram shows a ray of light moving from air into glass of refractive index 1.6. So refractive index is equals 1.6 here. All right, calculate the angle X. Calculate the angle X. So the angle X here is formed between the refracted ray and of course the boundary. and the boundary. Okay, so it is not the angle of refraction. The angle of refraction is right here. The angle of incidence is right here. Okay, so to calculate this one, we are going to use this formula. Refractive index is equal to sine I over sine R. Because we can only find this part if we find angle of refraction. So we are going to start by finding the angle of refraction. Refractive index is 1.6 is equals to sine angle of incidence. Angle of incidence here, it is not this one, but it is this part. And you know that the whole of this one is 90. So 60 minus 90, angle of incidence is 30. So sine 30, divide sine R. We cross multiply, we are going to have 1.6 sine R is equals to sine 30. Okay, divide 1.6, divide 1.6. So I remain with sine R is equals to sine 30 divide 1.6. So this one is just the same as the angle of refraction is equals to sine, you punch shift, then whatever you find when you divide sine 30, divide 1.6. Okay, so this one, if you punch on the calculator, is going to give you angle of refraction to be, the angle of refraction to be 71.8 degree. Okay, 71.8 degree. That is the angle of refraction. Now what we are looking for, it is not the angle, or what we are looking for is not the angle of refraction. So if this one we found to be 71.8 degree, we need to subtract from 90 for us to find this angle x here. And therefore 90 minus 71.8, it gives us 18.2 degree. So therefore the answer is A. Okay. All right, question question 15. The diagram shows the permanent magnet placed inside the coil from the direction of the arrow. What should have been the response on the needle on G as the magnet was being pushed into the coil? So when the magnet is being pushed into the coil, that is from the north, you push the magnet like this, the north. So what happens is that the needle will be deflected to the left. Okay, so the answer for therefore is A, deflected to the what? To the left. Okay, then question 16. Negatively charged rod is brought closer to an isolated T-shaped piece of metal. Initially, the metal is uncharged, which diagram shows the induced charge on the metal. So always know that the induced charge should be the opposite to the charge. Okay, so here we have the negatively charged rod, so it will induce the opposite one, which is positive, and this one is going to cause the separation of charge in this metal, which means the negatively charged will be pushed away, and of course the positive charge will be attracted to the metal rod, and therefore A is the answer. If you look at this one, there's negative, positive, but also there's positive here. Therefore this one is not. Negative, negative, this is no. Negative, negative, this is no. So therefore the answer is A. Question 17. An emission water heater is marked 240 volts, 2 kilowatts, and it runs for 120 minutes. If the cost of 1 unit of electricity is 0.80 kwacha, what is the cost of running this heater? What is the cost of running this heater? So the cost of electricity cost is equals to energy times what? Cost per unit. Cost per unit. Okay, so in this case we need to calculate energy, and energy is equals to VIT, which is power times time. Okay, time is supposed to be in hours, so this is where you get to use time in hours. Okay, so what we are given here, VI, we are already given power, which is this one, 2 kilowatt. Okay, and supposed to be in kilowatt. The power is supposed to be in kilowatt, take note. Okay, so power is supposed to be in kilowatt, then time in hours. So we have already power, which is 2 kilowatt. Okay, but the time we have it in minutes, so we convert it into what? Into hours. And we know that we have 120 minutes. Okay, you know that 1 hour is equals to what? 60 minutes. Okay, 60 minutes. So minutes and minutes will cancel. Then it's just the same as the 120 divided 60, which is just a 2. So multiply 2 hours. And this is going to give us 4 kilowatt hour. Okay, now we can multiply, we can find the cost. We said cost is equals to energy times the cost per unit. So you're going to have 4 kilowatt, or 4 multiplied by, what is the amount per unit? 0.80. If you multiply this, what are you going to have? What do you have if you multiply this? Okay, so you have 3.20 kwacha. Okay, kindly confirm this amount. So that is the amount that I found, and therefore here the answer is A. The diagram below shows a lamp, shows a 12 volt 3 amp lamp being operated by a transformer using a 240 volt supply. Okay, so now this is the main supply. So here, that is where you find the primary. Here, that is where you find the secondary. If the transformer is 100% efficient, what current will flow through the supply? So what they are telling us here is that this is an ideal transformer. And of course, to find the current that flows through the supply, you just use the formula of an ideal transformer, of which power on the primary is equals to the power on the secondary. So V S I S. So in this case, what is the voltage on the primary? The voltage on the primary is 240 multiplied by what is the current, is the one that we are looking for. Then what about on the secondary? What is the voltage? 12 multiplied by what is the current? 3. Okay, so here you have 36. Here you have 240 IP equal to, so divide 240, and therefore IP, or current on the primary, is equals to 0.15 amp. So the answer is A. All right. Question 19. The diagram shows an alternating voltage applied to the input of an oscilloscope. The sensitivity is set to 3 volts per centimeter. So 3 volts per centimeter, it means 1 centimeter is equals to 3 volts. Now they are saying, what is the maximum voltage? So to find the maximum voltage, you should consider this one as your starting line. Then of course you look at it from here up to the top there, or from here up to there. It's just the same. So from here up to there, they are saying 1 centimeter, and it's saying one box here is equals to 1 centimeter. So this small box is equals to 1 centimeter. Now how many boxes are there from this line up to the top there? You find that there are how many? 1, 2, 3, 4. So there are 4 boxes to reach this point here. So which means, what about 4 centimeter? What would be the voltage? Okay, so we put X. So 1 centimeter is equals to 3 volts. What about 4 centimeter is equals to dash? We cross multiply. So you're going to have 3 multiplied by X is equals to 3 multiplied by 4. You're going to have 12 volts. Okay, so the maximum volt is 12 volts. That is how you work out this one. Finally, the last question on multiple choice. A radioactive nucleus of an atom of an element emits an alpha particle. What change occurs to the apparent nuclide after the decay? So the general equation for alpha, when it decays, if you have an alpha particle with a mass number and atomic number, decaying by alpha particle, the mass number, let me say this is the nuclide, or this is the daughter. Okay, so the mass number decreases by 4. The atomic number, which is Z, decreases by 2. So the nucleon number is the same as mass number. So the mass number decreases by 2. This is no. Mass number increases by 4. No, it has to decrease by 4. Proton number decreases by 2. Yes. Proton number decreases by 2. Proton number increases by 4. No. So therefore the answer is C. Alright. So that is how simple it was. Otherwise we've come to the end. And of course, thank you very much for staying up to this point. If you've enjoyed the lesson, do not forget to subscribe. If you are interested for online lessons or physical lessons, you can contact the number 0976 402563. And do not forget to refer someone to this platform. Otherwise, see you in the next one.